We are going to talk some more about parallel and perpendicular lines. Last time you may remember that we talked about parallel lines have the same slope because in order for two lines to never meet, they have to be going up and over at the same exact rate. And we talked about perpendicular lines, which have slopes that are opposite reciprocals. And I'll give an example of that real quick because those are two words that maybe together sound like a really big, complicated thing. So opposite means that they are, one's positive and one's negative. Reciprocals means that they are flipped of each other. So if I had, say, 2/3, the slope that's perpendicular to that would be -3/2. Remember, reciprocals refer to us flipping over the fraction. And I've put slope-intercept form and point-slope form on here for funsies because what we're going to do is we're going to take information given to us about a line and find an equation of a line that's either parallel or perpendicular to that line.
I'm gonna choose red.
Okay, I'm gonna choose red. So number 1, it says parallel to the line y equals 5x plus 4 and goes through point -1, -8. And actually there's instructions above that may or may not be helpful too. So for each problem, write the equation of the line described, then graph the original and new line on the same graph. And you can write it either of the two ways, either in slope-intercept form or in point-slope form. It's up to you. And so since we're having to graph it, you might go, slope-intercept form seems like a better idea. Although it is possible to, you can graph from either form, but you might decide that you find it easier in slope-intercept form. It's whatever. So this first one we're talking about parallel to the line y equals 5x plus 4. So since parallel lines have the same slope and the slope of this line is 5, that means our slope is also 5. We are given a point, and so we can either use that to put it into point-slope form, which is y minus -8, so y plus 8 equals 5, and then x plus 1. Or you can plug all of those in for x, y, and m on slope-intercept form and end up with slope-intercept form. If you do that, you should end up getting let's see, this would be a -5 that I'm going to add over here, so that's -3. So in slope-intercept form, it's y equals 5x minus 3. So if we're graphing these, our first line starts at 4, goes up 5 and right 1. That's not 5, that's 4. There, that's the first line right there. Okay, and then the second line is y equals 5x minus 3, so same slope, but starting at -3. So and it might be a little tricky to actually draw lines that look parallel, especially if you, like me, have a 4-year-old trying to help you with this, but you know, that's how this goes. Yes. Now, what if they're perpendicular instead of parallel? That means we have a little bit more work to do to figure out the slope. This slope is 2. We want the opposite reciprocal, so +2 switches to negative, and 2 is 2 over 1, so that flips over to become 1/2. So we have this point 4, 2, the slope -1/2, and we can choose either to put it into point slope or into slope-intercept form, with slope-intercept form requiring a little more work. And you can graph from point-slope form, especially if you already know what the point is, because if I know that it's on the point 4, 2, I can make a point there. And then I know the slope is -1/2. Nothing says that I have to start at the y-intercept to draw a slope. I can draw it from any starting point that is on the line. So we can actually graph, this is the second line, not the original one. We can actually graph that without ever having to do slope-intercept form. And if we're careful enough, we'll actually figure out what the y-intercept is. It looks like it's a 4. So just throwing that out there. And then the first line, which I did not draw yet, starts at -1 and then goes up 2/1. And these should actually connect, as in intersect at a right angle, because, you know, that's actually what that's what perpendicular lines are, is they're lines that meet at a 90-degree angle. So it may not be perfect based on how good you are at drawing straight lines and things like that, but it should look more like a right angle than not a right angle. More like a right angle than a wrong angle. See you guys next week. Bye.